All right, so I'm gonna probably end up stitching these videos together. I'm assuming we'll have to do that in the aftermath, but looks like I left the previous one running, so I'm gonna have to do a little editing there, including what I'm saying now. Um, let's take a look at variables and data types. The thing that I was mentioning before we started going into this language review is that Python, one of its weirdest features, and it was very uncomfortable for me at first, is the fact that it doesn't really care about what kind of data you're putting into a variable, right? And a variable is basically a named spot in memory where you store things. Most languages will be strongly typed. In other words, if I want to put an integer or a floating point number or a string or some other complicated data structure into a variable that's named, I have to declare its data type first and then add that. Python does not care. I can drop a number into a variable. I can drop a string into a variable. Um, and then in the next moment, this one could change to a number and that one could change to a string and it would just not care. And I think that's really, really weird, right? When you know regular programming. Python allows for it, not that you really want to do that, but it's possible for it to do that. Another thing that we didn't really do much in our classes, but it is possible to take like three variables and assign them all at once. So like the one goes to the A and the two goes to the B and the three goes to a C. That is allowable in Python. And here's a really clever little way to swap values. So if you have a B and an A set, and then you're like, well, I want what's in B to go to A and what's in A to go to B, you would do it like this. Right? Pretty weird, but yeah, that's the thing. The data types that we have to work with is basically the two main ones are integers and floating point numbers. So integers are counting numbers, floating point numbers are with decimals or fractional amounts. And then they also have what they call complex numbers, right? And something that we didn't talk about, but basically putting you in the form of like an algebraic equation, right? Where you can use other variables in the mix. And really that, because the variables can hold just about anything, it Python allows for this, which is cool. We also can put in strings, which are basically a collection of characters. We can also do true false, right? So we can say, we call these Booleans, right? So it's one or the other. In Python, we do use a capital letter for the true or the false to start the word. Often when we're storing data types in Python that are Boolean, we often store them in variables that are named in the form of a question so that it's kind of self-answering when it's true or false. So we say is true or is false or is a number or something like that. You can also use this other type that we didn't talk about in class called none, right? So you can just actually apply that to a variable and just say, what's in that variable? Nothing. So in other words, you're creating it and you're putting in the type of none and it's waiting for a value to come in, but you can temporarily do that just to give it existence in the program, basically. You can also do this thing where you're checking the data type. So you can run this function called type, and notice this is put into a print command, and then it will output what that thing is. So if you have a variable and you've lost track of what kind of data is in it, you can run this print command and it will show you that it's an int or a string or a list or a class or something like that. So that actually goes beyond just integers and strings, by the way. We can convert between data types. So if somebody types in the number 42, notice the double quotes here, and then you want that to turn into a number so you can actually do math, you can use that int function again to do that, or the float function to turn it into a floating point number if needed. The other thing that you can do is you can take a numeric format and switch it to a string. Why would you do that? For output is one reason, right? Or to build a string is another reason. There's also conversions. So in other words, there is this 0 or 1 can be used for Booleans. And notice this is not something we did in my classes, but there's a type conversion for Booleans. So if you're using ones and zeros in a program that maybe you have a random number generator or something, and you want that to come in as a Boolean value, you'd have to use the converter. Notice that an empty string also is equivalent to 0 or false. The other thing that we learned about was the operators. So we have mathematical operators, and these are all, at least the first four are pretty normal in terms of math. So addition, subtraction, multiplication, and division. We also have what we call floor division when we use 2 forward slashes. And they give the example here. You're dividing, by the way, 3 into 10. And what you should get is 3.33 like you do here. But because this is floor division, it eliminates whatever's after the decimal point. The modulus is kind of the opposite, right? That gives us the remainder, right? So if we divide B into A here, 3 into 10, what's the remainder? You get 9, you multiplies into 9 and you have 1 as a remainder. Modulus is that weird one. So it's remainder division. And then Python also allows for exponential notation, right? So you use 2 asterisks to raise a number to a power, right? That's very handy notation. Very few languages do that, by the way. So that's a pretty powerful feature. We also have comparison operators. These are often used to run true false statements. And you'll notice that the output of all of these on the right, in the form of a comment, is indicated as true or false. And remember, whenever we do a single equal sign in Python, maybe it's better to look up here, right? This is what we call an assignment operator. So an assignment operator takes whatever's on the right side of the equal sign and stores it in the object on the left side of the equal sign. You guys probably heard me say that many times over. So whatever's on the right gets stored in the item on the left with a single equal sign. So it's good to get out of the habit of telling your brain that that's an equal sign. It's an assignment operator. Down here, though, when we start to actually check to see if things are equivalent, notice that we're using a double equal sign. And I like in my brain to say X is equivalent to Y. So the result of this would be false, given these numbers up here. And so that's why you're seeing a false there. The exclamation point in front of an equal sign is not equal. Then we have greater than, less than, greater than or equal to, or less than or equal to. Those are all comparison operators, oftenly used in situations where you're doing conditional statements, like an if statement, right? You're often comparing values or seeing if they're equivalent, less than, greater than, or something of that nature. We also have the logical operators of and, or, and not. And this is when we have multiple statements that we're checking. Typically with an and, both conditions must be true in order for the whole thing to be true. With an or, only one of them has to be true for the statement to be true. And the not, of course, negates what it is currently. So P right now is true. When we say not P, it's false. Right? Guys, I hopefully recalling some of this stuff. We start talking about the assignment operators. The basic one, once again, is just a simple equal sign. Whatever's on the right side of the equal sign gets stored in the item on the left side of the equal sign. You'll notice that we have all these what we call ternary operators. At least that's what we call them in other languages. And often, like we're incrementing through a loop or something, we'll use the plus equals. And that's basically equivalent. So when I say x plus equals 3, it's the same as saying x plus 3. And then we're storing it back at x. This is just a simpler, cleaner way to do it. So there's plus equals, minus equals, multiply equals, divide equals, floor division equals, even exponent equals, and modulus equals. I will say that a lot of people have a hard time conceptualizing the ones at the bottom of the list. The minus and the plus are really easy, because we're just adding a number or two typically. When you start doing this especially with like exponents or floor division, it can get pretty tricky. And so typically a lot of programmers stay away from that, but they are used. When we get to our if statements, and if statements are where, you know, we start to make decisions in our program, like you're walking down the path of your code, and then it's like, well, you're either going to go this way or that way, right? So you got to check and condition to see if it's true. So for example, in the first example, we have an age set at 18, and we're checking, is the age greater than or equal to 18? If it's true, then we execute the code that's indented. The indenting is required in Python. My understanding is you need a minimum of 2 spaces to indent, but this, and I think most IDEs will indent 4 spaces or 5 spaces. Whatever your indent level is, the indent has to be consistent. I can't indent one line 4 spaces, the next line 3 spaces, the following line 5. They all got to be the same. Otherwise, Python does not know that it's part of that block of code. Notice also that there's a colon here. So we're looking at basically this whole statement, checking to see if it's true or false. In this case, it's true, so this would output. Here's another example where the temperature is preset to 15, and then we're checking, is the temperature greater than 25? False. So this will not execute. So because that's not executing, we go to the else. This will print, you know, and it's correct. It's not hot outside if it's 15 degrees. Python also allows for if, else, if statements. And of course, they use the weird version of else if called elif, you know, for whatever reason. I don't know why. I wish I would fix that, but, you know, they're probably never going to. And in this case, notice how we are checking multiple values here, right? And remember, we did an assignment that was kind of like this one to check the grades. So if you're coming in with a score of 85, is it greater than or equal to 90? Nope. Is it greater than or equal to 80? Yes. This statement will execute. All the others will be ignored. If this number was, let's say, 55, not true, not true, not true, not true. So the else would print. Right? And it goes just in that order. The moment one of these statements rings true, then the code indented will execute and you're out of the structure. The processing would stop. So with the value that we have of 85, it hits true on the second check. This code would execute and then you're out. They also have this conditional expression approach here, which is kind of interesting, and Python allows for this. And notice that it says adult if age is greater than or equal to 18, else minor. So basically what it'll do is it will return this string and store it in status if the age is greater than or equal to 18. Else, it will do minor. And there is an alternate version of this, by the way, where we use the question mark and the colon to do it instead. But this approach works too. So basically what it allows you to do is to concoct a very simple if statement in one line. That's kind of neat, actually, right? That you can do that. I tend not to code like that, but you know, it is an approach. There are times when we're writing code that we need to take the code and get it to repeat. If you guys remember the concept of looping, there's basically 2 major loop structures in Python. One is the while loop, and then one is the for loop. The while loop will usually test a condition just like an if statement. So we're checking to see if the statement is true or false. This is preset to 0, right? So the count is preset to 0. So is the count less than 5? True. That means it'll output 0. It'll add 1 to the count and keep doing it. So what's this going to print? Remember, I had to do tests like this and Kahoots like this, right? So it's going to output 0, 1, 2, 3, 4. The moment it gets to 5, the while loop will set to false and it'll pop out of the loop. So this will print 0 through 4. It'll never print 5. Another example here. Here's a loop that's hard coded to run, right? So notice we're not doing a check. We're just saying while true. This is kind of a different type of approach. But this loop is forced to run because it's set to true. So it's going to take whatever our number is up here. It's going to add 1 to it, and then it's going to check. If the number is greater than 10, break. Break jumps us out of the loop. So that's our exit point. Otherwise, if the number mod 2 is equal to 0, continues. So in other words, when it's an even number, it will continue. It will also continue if neither one of those situations are true, and it will print all the numbers. Notice this prints odd numbers from 1 to 9. You can try that code if you wish. So both of these loop structures are useful. While loops are particularly useful for doing user interfaces, like if you want to give the user control of running a program continuously or not, the while loop is a good one. But you also have for loops, and for loops often are, in many cases, are the go-to loop structure for a lot of programmers, especially those that are experienced. Python has some really powerful approaches for working with for loops. One is the fact that we can declare something in a range. So the range here, there's a single value in this range command, which means that we're going to cover all the values up through 5. But notice computers start counting at 0, right? So it's going to go from 0 to 4. 4 is the 5th value. So you see how that was pretty weird, but that's what it would do. You also can declare the starting and ending point of a range. So you can use 2 values. So that's pretty common. And if you add the 3rd value, it tells you how much you're incrementing each time. If you don't include the 3rd value, it automatically increments by 1 each time. Now that saves you, this process like you do in a while loop where you have to manually control the increment. For loops operate automatically. They just automatically iterate. Remember that terminology? Iterate is to go through a loop once, one iteration. Another thing that it can do very elegantly is work with complex data structures without writing special code. So if I was like in Java and I wanted to iterate through a string, I would use a for each loop. They have a separate kind of loop for it. Here, I can say for every character in the string Python, print out each character. It will automatically traverse each letter without having to set up a range or anything and output each character separately. I can also do that with complicated data structures like lists, dictionaries, sets, etc. And here we have an example of a list of fruits, right? Apple, banana, cherry, right? So this is a list. You can tell it's a list by the square brackets, comma separated values. We'll talk about those in just a minute. But this is basically one variable that holds 3 strings. And we can look at that structure so we can traverse every fruit in fruits automatically and output its index position as well. So we can look at position 0, position 1, position 2. Remember all that? Yeah. We didn't do an enumeration thing when I taught the class, but we could say fruit in fruits and it would still basically work the same way. Another major language feature is functions, and sometimes we refer to these things as methods, but function is a formal name inside of Python. A function is a named block of code. You know you're dealing with a function when you see a keyword followed by parentheses. And a function is something that we create, so I can't use the same terminology that Python reserves for its own structure. So for example, the print function is a Python function that's built in. So I couldn't call my function print. Here I'm defining it. So, when you define a function in Python, you use def as the prefix. You name the function followed by a set of parentheses and then a colon, and then you're indenting your code. Once again, the indents have to be consistent. So you have multiple lines of code inside your function. They all must be indented the same depth. The thing that's kind of interesting about the parentheses, you don't have to send anything into a function, but if you do, you would place it here. And then the name of whatever thing you throw inside here exists as a variable inside the indented code, right? Now, you can define a function, but you also need to execute a function. The function will not execute automatically unless you call it by name. Noah, you have a question.
Yeah. So basically when you create a definition, is that like creating like a small library and it'll call back to it every time that you use that definition? I was always a little confused by that.
Yeah, it's just basically, you think of it like this. Like if you have a series of tasks that you always perform, you can bundle those together in one named function, and then with one function call, repeat all those steps automatically, right? So that way, this is not a good example because there's only one line of code in here. But what if it was like 25 lines of code? So let's say every time like a user signed into the system, you might say, "Hello, user. Today is whatever," and then yada yada. Might have 20 things that you do, and you could just bundle that all into that function, call it with one line of code, and all of it executes automatically rather than repeat the code continuously. If you get a collection of functions, that's really what forms a library, by the way, is a collection of functions.
Gotcha.
And hopefully that helps. Now, when we send information into a function, that's called a parameter or an argument, right? So it depends on where you sit, right? So if you call it an argument, it's what you're sending in. If you call it a parameter, it's what you're receiving at the function. So in this case, this function is receiving a name, and then that item becomes a variable inside the indented code. So name here, when you send in the value, will propagate to all the variable fields inside the function. If you include a value here, whatever you happen to name it, you better send one in. Otherwise, it'll throw an error. So if the function's expecting a value coming in, you better send it one. Can you have more than one parameter or argument? Absolutely. You separate those with commas, and then it's expecting to receive them in the order in which they're listed. So if I had like name, age, height, I would send in name, age, and height in that order. So here's a function defined, and this is a function call to get it to run. So just as an example, right? Let's take that over to the Jupyter notebook and just drop it in really quick. And let's run it, right? So hello, Alice. But if I wanted to run the function, multiple times, favorite, of course, you know, I don't have to like repeat all the code. Now, this is a very simple block of code. It's one simple command. But once again, what if it was 20 statements? I could execute all 20 statements with one function call. That's the point of a function. Do you have to use functions? No, but here's what happens is when you start to develop code, and if you come up with a slick way of completing an action, you can take that function and put it in your own little library and then import that file into all your programs and use it as a tool every time you're running the code. All right, let's keep pressing forward here. So that's an example of a function. Here's an example of a function with a return statement. So if you are sending values in, sometimes you don't expect it to send something back, but sometimes you do. Like, so for example, we created a function here called add. We send in two values, A and B, and it's going to return the addition of those two, right? So a return statement would send a value back. Whenever you call a function that has a return statement, you better have somewhere for that value to go. You're either going to store it in a variable or you're going to go directly to a print statement, one or the other. There are what we call default parameters, and we played with one example of this, if I remember right, with like an apartment number or something. So like if You want a parameter to always appear. I mean, I don't know why I would do it this way, honestly, but you can hard code it. So if it's not sent in, then you have a preset value for it. That's a approach. Here's the thing I was talking about before. So if you are sending in, uh, this information from an outside spot, so in this case, it's coming in from this function call here, you better send the information in the order that it's expected, name, age, or occupation. Otherwise, if you don't, then you have, if you're switching up the order and how you're sending it in, then you have to name them. This is not something we did in class together, right? I cover this feature, but it is possible to change the order, but you have to tell it what it means. Otherwise, it has to go in the order of name, age, and occupation. So John, 30, developer is the way it really should go. So if you want to set up a Python function that's going to accept an unknown number of parameters, this is kind of a weird one. That's possible too. Python allows for that. And this is, I'd call that more of an advanced language feature. So if I want to take all the numbers that I'm sending in and add them all together, this little routine here would do it. And it doesn't care how many numbers I send in, but notice the asterisks at the beginning of the statement. I could do this with strings. I could do this with numbers. If you're going to do that with words, then you use 2 asterisks, right? So that is variable keyword arguments. So in other words, you're sending in typically texts or variables. All right. Lambda functions is not something we talked about in our class, but basically what a lambda function is an anonymous function. In other words, it's a function that performs a task, but we don't give it a name. We just kind of brute force it. I'm not going to spend too much time on that. I don't think this is a super critical skill, but lambda expressions are very common in a lot of programming languages. And where you see them very typically used is when you're doing graphical user interfaces and somebody clicks on a button. Like, what does the button click do? It does this function. And you don't necessarily have to name it. It just performs it brute force. We have a bunch of different data structures in Python that we contend with. Probably the most important and most used one is the list. That's where we have square brackets. Items inside the list are separated by commas. And you can put strings in there. You can put numbers in there. You can put Booleans in there. And yes, Python allows you to mix all the data types. Most languages do not. Like, so in most languages, you do a list of integers or a list of strings or a list of floating points or a list of Booleans. Python is one of the only languages I know that allows for you to mix data types. Very weird, but also kind of useful. When you're trying to find an element in the list, I want you guys to remember, like this one here would be position 0, position 1, position 2. You just simply call the data structure and the position, and it will extract the information. They also have a neat little syntax. If you want to find the last item in the list, you just do a -1, it pulls in the last item. That's a really cool feature. Other languages would have you take the length of the list, subtract 1, and then you get the last position. You can do it that way too in Python, but hey, you got this thing, you may as well. There's also this feature called slicing. We didn't play with this in our coding in the Python class, but it was in our readings, if you guys recall. So if I want, I can take a slice of the data, so I can pick positions 1 and 3, for example, or I can take all the stuff that is basically up to the second position. Right? That's that syntax. That's pretty useful too. If you want to change the stuff in a list, I can explicitly change an item in a specific position, right? So I can change, the second position to orange. I can also add stuff. If I append it, it goes to the end of the list, or I can do an insert and it drops it into a specific spot. Index position 1 would be this one. This is 0. That's 1, 2, 3, 4. You can also remove a specific item either by name, or you can also do that by position. So like, for example, if I do a pop command, it usually will remove that particular item that you specified. You can also do this statement, which is kind of like our for loop statements, if you think about it, to check to see, is apple in the list called fruits? And this would return a true because it is, right? So that's the thing you can do. You can also take lists and join them together with a plus sign. So I can take my list of fruits, add another couple list items to it this way, or I can take my fruits list and multiply it. That's really weird. And double it in length and repeat the contents. Weird. Python allows for that weird stuff. We can do some other kind of weird stuff here as well. So for example, if we have some numbers, 1, 2, 3, 4, 5, and what this one will do here is it's trying to figure out how to take the square for all the for each number in numbers, right? 1 squared is 1, 2 squared is 4, etc. So it's almost kind of like a mini for loop. You guys catching that? It's kind of a weird little thing. And we do get people writing code like this because, man, that's a whole lot shorter than writing a for loop that does the same action, right? This one here does the same thing, and then will only output if you mod it by 2 and it's an even number. So only 4 and 16 show. 1, 9, and 25 are skipped. Strange, but what it does. You can sort lists with the sort command. You can also reverse the order of the items in a list if you wish. And you can also check the length of a list. Tuples, which are very similar to lists, notice that the difference is basically just the parentheses versus the square brackets. And here's the magic part of tuples, which is they are immutable, meaning they cannot change. So with a list, I can add stuff, remove stuff, pop stuff, add them together, multiply, do all these crazy things to a list. I can change them. They're mutable. But with tuples, whatever's inside those parentheses, whatever that data structure is, it's not going to change. You can use it for output, you can use it for analysis, but you cannot change the contents. And that's one of the reasons why we use tuples, especially with large data sets. Sometimes we'll take a list, convert it to a tuple just to do processing. Tuples will process faster because they don't have to change, right? So that feature is taken away, so it's going to be more streamlined. A lot of the same types of things happen with tuples. I'm going to kind of skip forward on this. Another important data structure here is dictionaries. Dictionaries are a key value pair set. So the data is not organized with an index position. It's not a numbered position. It's ordered by the key. So we get what we call key, right? This would be the key here. Name would be the key. The value is John. Notice that each key value pair is separated with a comma. The second key is age. The value is a number this time. The third one is courses. Notice this one's a list. And yeah, you could put any data type in either position. Here, all the keys are strings, but they could also be numbers. The dictionary, you can tell it's a dictionary by the curly brackets. And the dictionary structure is super, super close to the structure of a JSON file, JavaScript object notation, which has become a very hugely popular data transmission format for programming, right? So dictionaries feed well to that. Things are not looked up by index position, though. They are looked up by the key and the value. You can access stuff by using the key. So for example, if I say student and I'm looking for name, it's going to find John because that key is associated with John, right? You can also run a get command, right, which pulls back uh, whatever the value is for the key called age, and that would pull back 20. Right. This one here, if a default value, if the key doesn't exist, so if we're looking for grade and there is no grade, it's just going to return this value. So maybe your data structure doesn't even include that. You can change dictionary items directly. So you can just say, change the age key to 21, change the grade key to A. Or you can run the update command. Notice the syntax here. They basically do a complete replacement of the key value pairs. You can remove stuff. You can use the pop command, or you can use the delete and then just indicate which key you're deleting. It deletes both the key and the value associated. You can check to see if a key is there. So you know, is the key student or the key name in the student dictionary? In this case, it would be. We can check to see what the keys are, what the values are. So that would like save those as a list, basically, and what the items are. So that's kind of a fun one to play with, just to look at your data if you don't have access to it. And then you can also do some of those fancy operations like we were looking at before with lists. Another data structure is called sets. These are a little bit weirder because once again, the contents are not necessarily ordered. And notice once again with the way these are put in, notice that sets have unique elements, so stuff can't repeat, which is a little bit weird. You can add and remove stuff. You can discard stuff. Those are all actions that you can do. But if you think of sets, the concept of sets comes from the mathematical set theory. That's where you do unions and intersections and differences. And so all of those things are available here as well. And they show you how to perform those operations with these signs here. I'm going to keep moving forward here. Kind of the last major topics is objects and classes. And with objects and classes, if you remember the whole little spiel I did on this, but basically a class definition is where we take and create a blueprint, and the analogy I would always give in the Python class is before you build a house, you have to have a plan or like kind of a thing that you're following called a blueprint to build a house. And I think, the way I would always say it is like, if you're building a house, you don't just run down to Menards and buy a bunch of 2x4s and a hammer and nail and get busy, right? You got to have measurements. You got to have a foundation. You got to know how much wood you need, how tall it is, how wide it is, what materials you're using. And basically what a class structure does is it defines a blueprint for creating an object. An object is basically something that contains its own data field. So in this case, we have what we call the constructor function, and it declares basically the data fields or you can call these a bunch of different things. They're calling them instance attributes, but these are the internal data properties for that object. These are the variables inside the object. Here we just have a couple of data objects. We also have a bunch of what we call methods, which are basically functions that are inside the thing. So we can call those functions within the object. So the functions travel with the object. And they show a few different approaches here for doing that. An object is the actualization of the class. So in other words, I create this class above called person, right? And then to actually use a person in my code, I call the constructor function. I send in the information it's expecting, in this case, name and age. That gets stored here. So this person contains all of this code. The data fields, the functions, all of it is there. And what's beautiful about it is all of that capability is housed in one single statement, one single word. And then all you have to do to, pull the information back or utilize its features is to call the data features, like these would be properties, right? So if I want to access the person's name, I just call the object name and the name. It reaches into the object and pulls the name back, or the age, or the species, right, in this case. If it's got functions built in, I use the object name and then dot the function name, and it will execute the function. So that's really neat and very, very powerful. And really one of the secret sauces to programming is this object-oriented approach to creating things. There's also inheritance and all this other stuff. I'm going to kind of skip over that. We didn't go deep into that into the class, but you can read up on that if you wish. Python also has the elegant ability, and it is important in this class to be able to read external files, read them in, or read them in and write them, or create them from scratch if necessary. And these are all the techniques. I'm not going to go through this stuff all line by line because we'll review that when we're coding. But the fact that you can read in external files or write external files, and then the one that'll probably be important to us is working with CSV files, right? Often we get our data in those formats, and Python is very, very elegant at working with these things, right? So you can have a file that's got all this data in it. We can import it and process it and then use it to feed data for our code and then do whatever action it is. We can, analyze it, do math with it, create visualizations with it, etc. So these are really important little areas. So I'll have you guys read up on those. I talked earlier about working with JSON files, and probably the two predominant formats for moving data around in applications these days is either working with comma separated value files or JavaScript object notation files. And you'll notice CSVs usually work like lists, and then JSON, not sure what happened there. If you look at like a JSON object, right? Notice how it looks very much almost exactly like a dictionary, a key value pair. That's how JSON operates. So there's those correlations there between those two data structures. We learned as well about basic exception handling, and this is when you're writing code that might have a tendency to fail. So for example, if I'm asking a user to enter a number and they get snarky and enter a word that doesn't work, this code here could potentially fail, right? So we put in what we call exception handlers, that would throw error messages, but not stop the program from running. Without a try except structure, invalid input can crash your program. And what good is a program that crashes just because somebody put in the wrong kind of data? Not very good at all, right? All right, so that's just kind of a brief overview. They get into doing imports of various packages. We'll play with this as we do the exercises. So we have the math library is a common one to import. You can import very specific tools out of the math library. So from the math library, import square root and pi, right? So you can do math with those. You can also do imports and then use them as an alias. So you don't have to use the whole word math. Often what people do is they'll just abbreviate it with one letter. So this M here represents the math library, and we're pulling cosine out of it in this case. You can also use the wildcard, not really recommended, right? Because the math library is pretty huge. So you're like when you do an asterisk, you're importing the whole darn thing, whether you need it or not. It is considered better practice to pick the tools you need and then bring them in specifically. All right. They talk here about how to create packages if you want to look at that. They also talk about some of the standard libraries like working with the operating system, the date time module, random number generator, regular expressions, and system level things. This was generated by Claude, this whole little tutorial thing. And I think it does a very nice job of kind of conglomerating a whole course down into what we did that in like 45 minutes, right? All that knowledge. I understand that your heads are probably spinning from that because that's a lot of stuff to go through. Um, but here's the lay of the land, folks. I'm going to show you the assignment. We didn't get a chance to get to the coding of it, but we will walk through the coding of it next week. And I might also pre-record some of that content. There's a few different um, code things to do here. And we're going to do these all together. And I plan to kind of like record some of this in advance. So I'll try to like pre-release some of that, and then the rest we'll do in class next week. But if you look at the attached document, which you can't see from the screen, there is a CSV file here for you to work with. But here is the document that is designed to guide you through the exercises. So there is a kind of a complete breakdown, so it tells you what to do. And what I want you guys to attempt here, and I know this might seem a little overwhelming if it's been a while since you've done this, is try to write the code. And if you need help, normally I would say don't use AI, but you could ask an AI for a little bit of assistance. I'm kind of okay with that. The important thing is here to understand the code. I will go through next week and show you how to code all of these. It won't take very long. Most of these programs are fairly simple. So there's one that's a baseball game simulator, growth of an investment that plots and creates a bar chart. Right, so that's in there. Adding numbers together, a very simple adventure text-based game, a list of songs, and then processing a list of movies and extracting the text and taking a look at it. Right? So that's the general goal. Now, when you look at these instructions, there's sample output screens, so that the target is to make it look at least as good as that. But it also, the sample output shows you kind of how to code it and what's expected as well. Right. Once again, we will go through this in detail next week. So I'm not going to leave you hanging. All the solutions will be provided. But I would like you to make some attempts to try to code this on your own and see how you do on it. If you need to reach out to an AI engine to help you, that's fine. But I would prefer that you try to code it on your own. All right. I'm going to cap the video here in just a moment. I have one more topic I want to talk about real quickly, which I promised I would talk about. And that is this GitHub tutorial that I have here. I'm going to slide it up on the page a little bit. This is once again generated with the help of Clyde this afternoon. This is something I do like to talk about in my courses, but basically what this tool is, GitHub is a repository for storing your code. You can go to this website, which is very simple to get to. Just type GitHub, go to their main page, and either you're signing in or signing up. And when you sign in and create an account, it gives you a place to store your code for free. Right? Once again, whatever you put here is publicly visible unless you have a paid version of GitHub. A lot of developers use this platform very simply because it's the most popular one, real frankly, right? This is owned by Microsoft now. And this does have, if you notice up here, Copilot is built in. So you can actually kind of code on the site as well. That's a possibility, but most people use it to store their code files and then create multiple versions of them. And then what a lot of developers also do is, like when they're like job hunting, for example, they share their GitHub page with potential employers so they can see the kind of coding they've done. That's another reason I kind of point this out. It's not an obligation to use this tool, but it is something you might want to explore. Some employers do expect you to know how to use this tool, which is one of the reasons I kind of bring it into the mix at this point. So what I would recommend is that you just very simply look at some of the basics here, how to set up an account, how to get Git installed on your machine, and then creating some code repositories. And if you want, and I'm just kind of putting it out there, if you have all your old code files from the Python class, you could put them all up on GitHub, and then they're always out there for you to refer to if you wish.